Hello everyone, welcome back. This video will learn how we can interface LDR sensor with Arduino. So let's get started. LDR, this stands for Light Dependent Resistor. So this LDR, it's basically a photoresistor and is a passive electronic component. What does it mean? Being a passive electronic components for an LDR means that the LDR itself does not require an external power source to operate or function. Okay. In definition, we can say passive electronic components are those components that do not actively control the flow of electrical current, instead respond to changes in the environment such as changes in light intensity in case of an LDR. This LDR, its resistance changes with the variation in light intensity. So here's a plate on the LDR, and the resistance of the LDR changes in accordance with the light that fall upon the surface of the LDR. Typically made of semiconductor materials like cadmium sulfide, the higher light intensity leads to lower resistance. That means whenever there is light on the surface of an LDR, it will lead to lower resistance, and low light or dark means higher resistance. It provides a voltage that varies with ambient light conditions. This LDR, this is the basic LDR sensor, but it can come up with a package of such module. This module of LDR, this contains 4 pins. The first one is for VCC. We can supply 5 volt here. Then the second pin is for ground. The third and fourth pin, these are for signal obtained from this LDR to Arduino. Now the signal generated from this LDR is 2 types. It can be digital signal or it can be analog signal. So that's all for the basic stuff related to LDR. Let's talk about where we can use such LDR in our project. We can use LDR in applications like automatic street lighting, automatic solar lighting control. We can find LDR like applications in camera for exposure control. Or we can also find applications of LDR in displays for automatic brightness control. In home automation, LDR is a very common sensor where we can control the lighting of the house based on light using the LDR sensor. It's also a part of home automation, that is curtain control of windows based on lighting. So that's another application for LDR. So these are just some samples of LDR applications. There are many other applications where LDR can be used. So now let's jump into GUI and find how we can interface LDR with Arduino. Interfacing LDR with Arduino is pretty simple. Let's bring up an LDR here. Search for LDR. You'll find this photoresistor sensor LDR. So we need this one. The connection is straightforward. First, we need to connect VCC to VCC supply. So let's do that. Let's connect it to 5 volt. Then connect it to ground. The other 2 pin, one is for digital input and another one is for analog input. So we can use LDR for both purpose. Let's do this first. We'll first try out for digital input. We can take pin number 2. And also, if we want to use this as an analog sensor, we can also do so. Connect it to any of the analog pin. Let's connect it to A0. I'm putting it to another color and this to another. Okay. So now we will use this LDR to control LED light. So let's bring in an LED here. Also bring in a resistor. Okay. Let's connect the LED pin to 7 and remember to connect the LED pin with anode. So that's why we need to flip it. Let's connect the 7 number pin of Arduino to LED. Then with the resistor, let's connect it to the ground. Make the color to black. Okay. So now the circuitry king is complete. We have connected an LDR module with our Arduino at pin number 2 for digital input and A0 for analog input. We have also connected an LED with the 7 number pin of Arduino. Through our resistance, I have provided the ground here. Now let's do the programming. What do we want to do? In this demonstration, we want to build an automatic light dependent lighting. That means whenever there is light, the LED should turn off, and when there is no light or dark, it will turn on the LED. So let's do that. First, we'll define the pins here. Let's define a pin for LDR pin, and the LDR pin is connected to 2 number pin of Arduino. Then again, let's define a pin for LED pin. The LED has been connected to 7 number pin of Arduino as per our circuit. So that's all for the pin definition. The next step is setting pin modes for this pin. Okay, let's do that. Pin mode, LDR pin. The LDR is our input here. And then pin mode, LED pin. LED is an output for our circuit. Okay, the step 2 is done. Now comes the third step, developing a logic for our project. So before writing the program, remember that whenever we are working with this LDR module, highlight means low digital rate and low light means high digital rate. So keep this in mind, and using this logic, we'll build the program for our LED lighting based on lumens of LDR. Okay, so let's do that. If digital read of LDR pin, so what happens when there is no light or low light, it gives high. So let's do that. High, that means no light or dark. We want to turn on the LED. Okay, LED pin, high. So this is situation for dark condition. Now it is dark and we have turn on the LED. Next, if it is not dark, there will be lumens, and high lumens or high light means low digital. That is why it will come here in else statement, and in else statement we want to make the LED off, low. So that's the simple logic for LDR. It could be confusing at the beginning, but remember how to give the logic here. Let's run the simulation here. So now let's give lower lumens. So the lumens is lower, or we have dark at the environment. So that is why the LED light has turned on. If I go for higher lumens, around 100 lumens, it has turned off the LED. Okay, so if you want to see exactly what is the lumens value, you can use the analog read for this A0. Okay, let's do that also. We'll initiate the serial monitor with 9600 baud rate, and we'll print serial.print sensor value. After that, analog read A0. Then give a escape sequence for new line. So this will print the analog value that we obtained from this analog signal print of LDR. Let's rerun the simulation here. So if it is 0 or around 0.1 lumens, it is giving higher value, just like we obtained. Lower lumens give higher digital read. So lower lumens is giving higher value. And if you go maximum, higher lumens give lower value. Higher lumens or higher light gives lower value. So this is also proven from the analog read. I hope you got the idea. So that's all for this video. I hope you have built a concept of LDR, how to work with LDR module, and how to develop logic for LDR based projects based on their reading from digital pin as well as their analog pin. So I will see you all in the next video with some new exciting steps. Thank you.